Assalamu alaikum wa rahmatullahi wa barakatuh. Today our lesson is about rational exponents. Before we begin, let me divide the title into two parts. The first part is rational and the second one is exponents. Let me define what do we mean by rational number. Rational number which can be written in the form m over n, or in other word, it is a fraction, okay, where m and n are integers. But n cannot be zero because integers are negative, positive numbers, and zero. But n we cannot put instead of it zero. Notice that integers themselves are rational numbers since, for example, 5 equals to the 5 over 1. Any number without denominator, I told you that before. Any number without denominator, we can put for it a denominator, which is 1. For example, negative 6, since it is positive or negative, okay? When we want to make it as a rational number, or write it in the form m over n, we just put 1 under it. Okay, this is the part rational. What about exponents? Exponents, we mean number to the power. Okay, for example, 2 to the power 3. We took it before, which means 2 times 2 times 2. So we repeat 2 3 times and by multiplying them by each other. Okay, today our topic is about rational exponents. Here, the power was an integer. It was positive number. This is before, we learned this before, or zero or a negative number. But today, the power should be rational, should be a fraction, something over something. For example, 3 to the power 1 over 2, or 5 to the power 2 over 3. In this section, we will deal with these numbers, and the fraction here, or the rational form of the power, means something. We will know it later on. Before we begin, let me make a quick revision, okay, about exponential laws. If we have two numbers, for example, two numbers with the same base, but we have different powers, 2 to the power 3 times 2 to the power 2. In multiplication, we take the same base, 2, and we add the powers, okay? 3 plus 2, which is 5. And division, if we have, for example, 5 to the power 7 divided by 5 to the power 3, we have the same base. We take one of them, okay, or 5. And division, we subtract the power 7 minus 3, which is 4. Or we can write it in this form, okay? It's 5 to the power 7, okay, divided by 5 to the power 3. So we can write division like this or like this, the same answer. Okay, and we took also power to the power, 7 to the power 2 to the power 3. If we have power to the power, we multiply both powers together. So we take 7 here, 2 times 3, which is 6. We have also anything to the power 0, for example, 7 again to the power 0 equals 1, or negative 2 to the power 0, which is 1. And we took a negative power. For example, if we have 2 to the power negative 3, it means 1 over 2 to the power 3, right? Okay. And let us make it more complicated. For example, if we have here 2 to the power 3 times, negative 3 times 5 over 7 to the power negative 1 times 3. Here we have two different numbers, 2 to the power negative, or they are 4 actually, to the power negative 3 times 5 over 7 to the power negative 1 times 3. We have negative powers right there. We put this like 5 negative powers mean we have to change the position of the number. If it is in the numerator, we should put it down in the denominator, or if it is in the denominator, we have to raise it up to the numerator. So we have here already, we had 5 times. What do we have from here? Should be positive 7 to the power 1. Here we have 3 times 2 to the power 3. It becomes 3 because we put it from numerator to the denominator. These some laws we took them in the previous sections about exponential laws. It was the power was integer, negative number, positive numbers, and 0. Okay, let's move to the next part of my lecture. Let's make this investigation before we begin with powers or rational powers, okay? 5 to the power 1 over 2 times 5 to the power 1 over 2, whatever. Okay, I know this is the first time you deal with such these powers, but let us deal with it as normal multiplication. Okay, we take 5. In multiplication, we add the powers 1 over 2 plus 1 over 2, which is 5. 1 over 2 plus 1 over 2, which is 5 to the power 1, which is 5. Okay, this is surds and radicals. We took them before. This is the square root of 5 times the square root of 5. It becomes 5. We took it before. Here, this is the degree of the root. If we don't put anything, we mean it is the degree is 2. We have also 3. Okay, cubic root, and we have the root of the degree 4. Okay, so if we have like this, for example, cubic root of 3 times, if we multiply it by itself 3 times, okay, we can take 3 by itself. If we have the root with the degree 4, so we have to multiply this root by itself 4 times to take the number under the root by itself. Okay, I hope it is clear. So here, the degree of the root, it's a square root. So we don't put the 2, okay? So square root of 5 times square root of 5, which is 5. Let's make this 3 to the power 1 over 2 times 3 to the power 1 over 2. In multiplication, we add the powers. Okay, so we have 3 over 1, 1 over 2 plus 1 over 2, which is 1, 2 over 2, which is 1. Okay, 3 to the power 1, which is 3. Again, square root of a 3 times square root of a 3, as we did it before, which is 3. 13 to the power 1 over 2 times 13 to the power 1 over 2. So it is 13 because we add the powers, whatever the power is, it is. Yani, here it's 1 over 2 plus 1 over 2. Because in multiplication, if we have the same base, just we add the powers, okay? Here in general, if we have a to the power 1 over 2 times a to the power 1 over 2, just add it. We put a 1 over 2 plus 1 over 2, which is 1. So it is equal to 1. The square root of a times the square root of a, as we did this, but instead of any a specific number, we put any integer, so the answer is a. Okay, now let's move on to the next part. 7 to the power 1 over 3 times 7 to the power 1 over 3 times 7 to the power 1 over 3. In multiplication, we just add the powers. Let me do it here. 1 over 3 plus 1 over 3 plus 1 over 3. We have the same denominator, so we can just add 1 plus 1, which is 3 over 3, which is 1. Okay, so 7 to the power 1, which is 7. Here we have cube root of 7 and multiplied by itself 3 times. I explain it just right now, so we have here 7, okay? The same thing for 8. 8 times 8 to the power 1 over 3, 3 times. It is, we add the powers 8, and here we have 8. Before just continue this page. Let us notice something. If we compare this with this and this with this, because we have the same answer, what do you think? What do you think about 2 and the degree of the root? What do you think of this? Here we have a 3 and the degree of the root, which is important to be noticed. Let's go. Here we have in general, okay, a to the power 1 over 3 times a to the power 1 over 3 times 1 a to the power 1 over 3, which is a to the power 1, which is a, because we add the powers. Again here, the cube root of a times the cube root of a times itself again, which is a. From the investigation, you should have concluded that a to the power 1 over 2 equal to 1 to the square root of a. Again, a to the power 1 over 3 equals to the cube root of a. So in general, if n is a positive integer, this one which is in the denominator, okay, a to the power 1 over n means when we, sorry, it's n. When we see this formula, just replace the power or the rational power by a root, the power or the degree of the root, which is the denominator, we put it right there. And this one, okay, it is the power of the a itself, because in the next section you will discover this. It is not mentioned here, but you will discover this later on. So the number in the numerator should be what? The power of a. So we are the a, which is the base, it is the number under the root. The root, the degree of the root. What do we mean by the degree of the root? Which is the number. We put it right there. If it is 2, don't put anything, okay? From 3 and so on, you can just write the number. Here, small number. We put the degree of the root, which is the number in the denominator, and the number in the numerator. Here, all of our examples were 1, but next section, inshallah, we will deal with other numbers. This number should be the power of a, or the number under the root. Let us make or see some examples. Evaluate. Evaluate, you need to find the answer without using the calculator, okay? 16, let's analyze the problem step by step. I told you, when you see, okay, here, okay, when you see the power, a rational power, just put a root. We don't know until now what is the degree of the root. The degree of the root, the number we put it here. We can guess it or we know it from the denominator of the rational number of the power. We said that before. Rational exponents. The power is a rational number. Rational number is a fraction. So the denominator of the fraction, which is the degree of the root. Here we have 2. I told you that. You don't have to put 2. We have the number is 16. Here the 1, which is the power of the 16. Just don't put it. Any number to the power 1, which is 1. What is the square root of 16? What's the two numbers? We multiply them by each other to have 16. We have positive or negative 4. Let's move to this part. We have here a negative power. Before doing anything, just convert it to what? A positive power. We put it, we make it like this. We put it 16 to the power negative 1 over 2. We put it in the denominator. So it's 16 over, or to the power, sorry, to the power 1 over 2. Now, 1 over, when I see a rational exponents. I mean, I have a root. What is the degree of the root, which is the number in the denominator, which is 2? So I don't have to put it. Here we have 16, the number itself. Okay, what is the number in the numerator? It is 1, so 16 to the power 1, which is 16. Now let's do it. Here we have 1 over the square root of 16, which is 4. Because we have positive and negative numbers, so it's positive or negative 1 over 2. 1 over 4, sorry. Here we have a to the power 1 over 3. Now, when we see a rational exponents, we mean that we have a root. What is the degree of the root, which is the number in the denominator? Let's put it right there. Okay, because it's a 3, we have to write it. Here we have 8. What is the power of the 8, which is 1? So we don't have to put it. What is the number? We multiply it by itself 3 times to have 8, which is 2. This is the meaning of the cube root of 8. Okay, here we have again a negative power. So convert it directly to a positive power. So we put it in the denominator like this. Sorry, before converting it, let us do it step by step. So it's 8 to the power 1 over 3. Now we keep 1 over, okay? We don't just do anything with 1 over. Now, 8 to the power 1 over 3. When I see any number to a power, which is rational power, we just convert it to a root. The degree of the root, which is 3, because here in the denominator we can see we have a 3. 8, the number to the power 1. We don't have to write 1. 1 over, what is the number? We multiply it by itself 3 times to have 8, which is 2, so 1 over 2. Okay, this was evaluating some numbers. Now let's move on to write in exponent form. What do we mean by this? This question means that we have this formula and I need it in exponent number to the power. Okay, so when we see a root 3 to the power, we have to put this line to prepare ourselves to make a rational number. What is the degree of the root? If we don't find any number here, we mean that it is 2. What is the power of a 3, which is 1? So 1 over 3. Okay, let's do this. 7. Okay, we put 7 as a base. We have a root, so we prepare ourselves to make a rational number. Okay, what is the denominator, which is the degree of the root? Here we put the 3 and 7 to the power. There is nothing. 7 to the power nothing means 7 to the power 1. So it's 1. Before anything, just put the root in the numerator, so we make it, or before do it, let us make it like this, 1 over, okay, 7, the base to the power. Because we have root, we have to prepare ourselves to make a rational exponent. The degree of the root, which is n, here, 4, and the power of the 7, which is 1. Now, we put it in the numerator. 7, because we changed the position, we convert it to a negative, okay, power. This is everything about rational exponents. Wait for me. The next video will deal with numbers with power under the roots. Okay, hope this video is useful. Study well.